Hi, Math 30-1s. Welcome back to Trig Functions and Graphs, Lesson 5. Today's lesson is probably one of the most important lessons, okay? We're going to be discussing not only for this chapter on Trig Functions and Graphs, but extending into the second chapter on trigonometry, which is equations and identities. So please take your time with the homework that you're going to be assigned today. Take your time with the lesson. It is a really long lesson. So if you need to break this into 2 sittings or even 3 sittings, okay, I understand that. It's pretty intense in terms of what we cover and what we have to take away from it. I will, trust me, I will emphasize the important things and I will let you know what is less important. But there'll be a lot of highlighting, a lot of writing in the margins, okay, a lot of things that we need to make sure we understand moving forward, okay? So any questions, as always, okay, email me, get a hold of me, and let me know what I can help you with moving forward. So in the title here, it talks about something called special triangles, exact values, and what we're going to be creating called the unit circle. So before we get into a lot of that stuff, what they talk about here are kind of our special angles, okay, and values that we are going to see over and over and over again, okay, repeated. So 0 degrees is equivalent to 0 radians, okay? 30 degrees, okay, is equivalent to pi over 6. Remember, 180 divided by 6 is 30, okay? 45 degrees, okay, equivalent to pi over 4 radian. 60 degrees, equivalent to pi over 3, okay? And then 90 degrees, okay, equivalent to pi over 2, okay? We're going to be using all of those values as reference angles, okay? Do you guys remember reference angles? Okay, they're the angles that we refer to discuss the sine, cosine, and tangent of larger rotation angles. So those are the angle measurements, both in degrees and radians, that we have to become very accustomed to, okay? And you're going to see them over and over and over again. So to study how we create these special triangles, reference triangles in the unit circle, okay, we're going to do a little bit of an investigation here. So it says diagram 1, which is just to the right, shows an angle of 45 degrees. And you can see that labeled right here, okay, in quadrant 1. That would be our reference angle, the angle we are referring to or discussing in this question. Okay, it's a 90-degree triangle. Again, just imagine some point up here on the vertex. You would have to go x units to the right. Okay, you would go y units up. Okay, and again, in quadrant 1, both of those dimensions would be positive. So it says the terminal arm has a length of 1 unit. So you can see they're calling this the terminal arm, okay, of the rotation angle. So pretend this is the terminal arm that's gone like this, okay? And it has a length of 1 unit. Now on a unit circle, which is what we're building, that hypotenuse of that triangle or that terminal arm will always be 1 unit, okay? And it says an isosceles triangle has been drawn. Now, do you guys remember what an isosceles triangle is? Well, an isosceles triangle has 2 sides and 2 angles that are the same. So therefore, if this angle down here was 45, then that means this angle up here must also be 45 degrees. Remember, the interior angles of a triangle always add to 180. So just by using our math and subtracting from 180, we know that that angle up there should also be 45. Now, determine the length of the equal sides of the triangle, okay? Give your answer as, and again, you're going to see this a lot now, as an exact value with a rational denominator. Okay, so we're going to have to do a little bit of cleaning up of our calculations here, I'm assuming, at the end of this question. So here's what we know. Okay, again, like I said, this would be an x dimension of the triangle, and this would be a y. So therefore, using Pythagorean theorem, it would look like this. X squared plus y squared is equal to r squared. We've seen that calculation before. Now, in this question, we know x and y are exactly the same length because it's an isosceles triangle. So again, I could pick the x or the y, it doesn't matter, but I could just say x squared plus, and instead of a y, I can have another x squared because they're the same length, equals r has a value of 1, and 1 squared is 1, okay? So now if I have x squared plus x squared, that's 2x squareds. So 2x squareds will equal 1, okay? So x squared will equal 1 over 2, and then x would equal plus or minus the square root of 1 over 2, but okay, x in this dimension is going to be positive, isn't it? So it's going to be just the positive 1 over root 2. Now going back to what we know about radicals and even from Math 10, this is the same as saying the root of 1 all over the root of 2. which is 1 over root 2. So there's a good calculation. But because of that part where they say we need a rational denominator, I have to rationalize the denominator by multiplying both the numerator and denominator by root 2. Okay, and when I do that, I get a value of root 2 over 2. And there is your side lengths. Okay, so both x and y in that question are root 2 over 2. Okay, so what we're learning here is that when I have a 45-degree reference angle, okay, a 45, 45, 90 triangle, the x and y dimensions are going to be root 2 over 2, and the radius would be 1. So moving on to part 2, it says use SOHCAHTOA, okay, which are, again, is the acronym which helps us remember the side ratio lengths in a right angle triangle, or x, y, and r formulas to complete the following. So what's the sine of 45 degrees? Well, again, when I talk about sine of 45 degrees, okay, sine is opposite over the hypotenuse. So that would be root 2 over 2 over 1, which would just be the root of 2 over 2. Okay, cosine. So cosine is always the adjacent side over the hypotenuse. So again, root 2 over 2 over 1, which is root 2 over 2. And then tangent, okay, tangent is always opposite over the adjacent. Well, that's going to be root 2 over 2 divided by root 2 over 2. So anything divided by itself is always a value of 1. Okay, so there's the values. Now below, they're doing the exact same thing. It's just that the angle measures, they're giving to you in radians instead of degrees. So the values, okay, of the ratios are going to be exactly the same. Okay, so this will be root 2 over 2. This will be root 2 over 2. Okay, and this will be 1. Okay, so it doesn't matter whether they give you the angular measures in degrees or radians. Okay, the value of the ratios will be exactly the same. Okay, diagram 2. Now, in diagram 2, I have an angle of 60 degrees, okay, again, which is the same as pi over 3 radians, and again, the terminal arm is 1 unit, okay? So what we're really focusing on here, okay, is this triangle right here, okay, that I will outline in blue, okay? It's kind of like the triangle we had in diagram 1. There's the hypotenuse, or the terminal arm. Here is the reference angle of 60, okay, and here's what they've told us. I have this time an equilateral triangle. Well, an equilateral triangle, each of the angles is 60 degrees, right? So that would be 60 degrees there. This would be 60 over here. And then this whole angle at the top, from here to here, would be 60 degrees, okay? But when I draw that perpendicular line down the middle, okay, it bisects that angle, which means this angle here, okay, will therefore be 30 degrees. Okay, so that's what we're talking about. It says determine the length of the altitude. So the altitude, okay, is this A, okay, the line that I dropped down from the top angle or vertex, okay, down to the x-axis, the positive x-axis. So I want to know what that is. So I'm going to use that blue triangle, okay, and use Pythagorean theorem again. So remember, this is the x dimension of that triangle. The A value is really the y, okay? So I go x squared plus y squared equals r squared. Okay, always start with the original formula. In this case, okay, I have x squared. Now, they've also told me the terminal arm is 1 unit, and if it's an equilateral triangle, okay, then this would be 1 unit, and the whole length along the bottom would be 1 unit, meaning from here to here would be half of a unit, wouldn't it? Okay, because that whole length has to be 1 unit, so 1/2 and 1/2, okay, gives me 1, so the x dimension is just 1/2. So this would be 1/2 squared. The y value is that altitude they're looking for, and the radius is 1, and 1 squared is 1. So I'm solving for that altitude. So a squared will equal 1 minus 1 over 4. Okay, 1 over 4 is what? That's 1 over 2 squared. So a squared will therefore equal 3 over 4. Okay, that's what 1 minus 1 over 4 is. Take the square root of both sides, okay, and that will be plus or minus the root of 3 over 4, right? So plus or minus root 3 over 4, which is root 3 over root 4. Again, we're going up, so it's positive. So this would be root 3 over 2, okay, and there's the altitude of that triangle. So now, when I go, okay, and I want to calculate the sine of 60 degrees, okay, here's what's going to happen. Again, I'm focused on that 60-degree angle, okay, which is this angle right here. Okay, and again, sine is what? Sine is always the opposite side, which is this, over the hypotenuse. Well, that opposite side, which was the altitude, was root 3 over 2. So root 3 over 2 divided by 1 is root 3 over 2. Okay, the cosine of 60 degrees is always the adjacent side over the hypotenuse. Okay, so what is that adjacent side? Well, remember it was 1/2, wasn't it? So that's 1/2 over 1, which is 1/2. And then this is where you have to do a little bit of work, okay? Tangent of 60. So remember, tangent of 60, okay, is going to be opposite over adjacent. So when I do that calculation, the opposite side was root 3 over 2, okay, all over 1/2. Okay, remember this line means divided by. So this is very similar to saying root 3 over 2 times 2 over 1. When I do that, these 2's will cancel, and that will leave you with root 3 over 1, which is just the square root of 3. So that's what the tangent of 60 is. And again, just below that, you're going to have the exact same values for those ratios. It's just that they have given us the angular measure in radians down here rather than degrees, but the value of the ratios, okay, will be exactly the same. Okay, one more triangle that we need to discuss, okay, in the same terms. So this triangle we're going to talk about here is really the triangle from the last question, part B, but it's just turned on its side, okay? And what I mean by that is this time my reference angle is 30, which means I'd have a 60-degree angle up here, okay? So what's going to happen then is if I switch those angles, you're going to see the side lengths are actually switched. So this is going to be 1/2, and this is going to end up being root 3 over 2, okay? That's a 3 there. And that's what I'm talking about, that length from here to here is root 3 over 2, okay? So when I go and fill in the ratios, sine of 30, remember sine is opposite over hypotenuse, so that's 1/2 over 1, that's 1/2, and again, I can fill that in for both of these, they're the same angle, but one in radian, one in degrees. Cosine of that 30-degree angle, okay, will be the adjacent side over the hypotenuse. So root 3 over 2 over 1, which would be root 3 over 2. Okay, and again, I'll fill that in for both degree and radian. And then just like the last question, tangent is going to be a little more work because I have to calculate the opposite side over the adjacent side, which will end up being 1/2 all over root 3 over 2. Okay, this is divided by, so this is like saying 1/2 times 2 over root 3. These cancel. So that will give you 1 over root 3. But again, they're going to want you to rationalize that denominator. Like so. So you'll get root 3 over 3. Okay, and that's what you get for the tangent of 30 degrees or the tangent of pi over 6. Okay. So what we've done in those 3 examples, it was a lengthy process, but I think worthwhile in terms of seeing the calculations, is we created these special triangles here. Now, from these triangles, what we have is this table just below and to the right, okay? And what we want to do is be very, very, very familiar with this table, okay? We want to know these inside out and as quickly as we possibly can. 30 degrees, 45, 60, the same as pi over 6, pi over 4, and pi over 3, okay? Just in degrees and radians, okay? Those are going to be the reference angles that we see a whole lot. So the faster we know the sine, cosine, and tangent of those values, the faster and more efficiently we can deal with questions. So if you take a look back at what we did on page 1 and page 2, or take a look at the triangles above, I'll show you what we're doing here. So sine, and we'll deal with 30 degrees or pi over 6 first. Remember, sine of 30 degrees, so you go to where 30 degrees is your reference angle, and sine is always what? Opposite over hypotenuse, right? So 1/2 over 1, so the sine of 30 degrees is always 1/2, okay? When I talk about the cosine of 30 degrees, okay, remember cosine of 30 degrees is always adjacent over hypotenuse. So root 3 over 2 over 1, so that's going to be root 3 over 2, okay? And then finally, the tangent of 30 degrees is always opposite over adjacent, okay? And if you look back, okay, we end up getting, and that's just up above at the top of this page, root 3 over 3. So those values we want to know. Okay, then I move on, and I now move on to the 45-degree triangle, okay, which is the triangle in the middle. So here is my reference angle, okay. So the sine, again, opposite over hypotenuse. So that'll be root 2 over 2. Okay, cosine is going to be the exact same thing because the side lengths are the same, and so are those angles on the interior. Okay, so you get root 2 over 2 as well for the cosine of 45 degrees. And then the tangent is nice as well because for tangent, okay, it's always opposite over adjacent. Well, that's the same thing divided by itself, so that's 1. All right. And then finally, we move on to the triangle, the 60-degree triangle. Okay, there's my reference angle. Remember, this is actually the 30-degree triangle, just on its side. So the ratios, okay, end up being switched from the 30-degree triangle. So when I talk about the sine of 60 degrees, remember, sine is opposite over hypotenuse, root 3 over 2 over 1, root 3 over 2. Okay, then that's the sine. The cosine, again, the adjacent side over the hypotenuse, so 1/2 over 1, that's 1/2. And then a little more work again, remember, for the tangent, okay, because tangent is always the opposite side over the adjacent side. So root 3 over 2 over 1/2, okay. So when I cancel the over 2's, you end up with the square root of 3. Okay, here I cancel the 2's, I end up with root 3. So there are the values, and again, that table you want to know, okay. Again, the faster and the better you know that table, the easier your life will be moving forward, okay? Now, in each of the triangles above, the horizontal distance, okay, of the triangles was x, okay, like I had mentioned to you, and you can see in this diagram. The vertical distance is y. Now, the hypotenuse is always 1. So remember, when I talk about a sine ratio, okay, the sine ratio, and again, we would be discussing this triangle in terms of having some reference angle down here, and again, I'll call that theta. So the sine ratio, remember, would be the opposite side over the hypotenuse. So when I go and calculate that sine ratio, it would be y over 1. Well, that's just y, isn't it? Okay, anything divided by 1 is the numerator. When I go and I talk about the cosine ratio, cosine is going to be the adjacent over the hypotenuse. So that would be x over 1, which would just be x. And then finally, the tangent ratio is always opposite over adjacent, so the tangent ratio will be y over x. Okay, so sine is the y value, cosine is the x value, and tangent is going to be y over x. So that takes us into the beginning of creating the unit circle. Now, what they've drawn here, okay, and I want you to be aware of as we move forward, is this. The unit circle, okay, is going to be taken up by all 4 quadrants, okay? You're basically going to have, a circle, okay, that goes around all 4 quadrants, kind of like so. What they're dealing with is right here in quadrant 1. What they're creating is here in quadrant 1. Once I know quadrant 1, I know the other 3 quadrants, because all I'm doing is whatever I create in quadrant 1, I'm reflecting over either the y-axis, okay, to get into quadrant 2, and then I can reflect over the x-axis to get down into quadrant 3, or I can start in quadrant 1 and reflect over the x-axis and get down into quadrant 2. But the points are all going to be exactly the same. It's just that when I move into the other quadrants by reflecting them, the x and the y dimensions will become possibly negative, okay? Or the y's will be negative depending on which quadrant I end up in. And you'll see that as we move forward here, okay? So here's what happens. They've basically drawn here, and it looks a little confusing, but they've drawn 3 triangles, okay? So they have this triangle here, okay, which I'm outlining in blue, okay? And that would be when I have a reference angle of 30 degrees, okay? And you can see that 30 degrees or pi over 6. So when I have a right angle triangle with a 30-degree reference, okay, which would be down here like this, okay, there's your 30-degree reference angle, or pi over 6 radians, you need to know the dimensions of that 30-degree triangle. So if you look at your 30-degree triangle from the other page, it's going to be root 3 over 2 and 1/2. So those would be the dimensions of that triangle. Root 3 over 2 and 1/2. That's how you would get to this point right here that I've circled. Okay, so when I label that diagram, okay, this would be root 3 over 2. Okay, and the height of that triangle is 1/2. So there is the blue one. okay? The red one, okay, we go in the middle. So the red one I'm highlighting here is going to be your 45-degree triangle, okay? Here's the reference angle for the 45-degree triangle, and you can see that that's 45 or pi over 4. Well, we know with that triangle, the x and the y dimension are exactly the same, which is root 2 over 2. That's why we like that triangle, because the x and the y dimensions are the same. So the dimensions are root 2 over 2 and the root of 2 all over 2. Okay, and then the final one, which I will draw in black here. Okay, oops, I went off that a little bit. That's not fantastic, okay? So as I draw that here in black, okay, the reference angle that they are discussing is from here to here. Okay, and this is, remember, the 30-degree triangle on its side. So now we're talking about 60 or pi over 3. So it's 1/2 and root 3 over 2. Okay, so 1/2 and root 3 over the 2. That's the height of that triangle. Okay, and again, for all three of those triangles, the hypotenuse is 1 of those triangles, or the terminal arm is 1. So what that takes us to are the two spots that I haven't discussed yet, okay, which is 90 degrees up here or 0 degrees down here. So you basically picture that terminal arm just rotating all the way up to 90 degrees, okay, which would be up here. So if that arm rotates from here all the way up to here, okay, that point would be what? 0 and 1. Okay, if that terminal arm fell all the way down here, okay, then that point would be 1 and 0. 1 unit to the right, no units up or down. So write the lengths of the horizontal and vertical line segments indicated and the coordinates of the 5 points marked. That is done. How do the coordinates of the points relate to the measure of the rotation angles? Okay, well, again, the x coordinates, okay, as we've seen, are the cosine ratios. Okay, so x is the cosine ratios, and the y coordinates, okay, are the sine ratios, aren't they? So again, that's actually a really important point, okay? So the x dimensions, okay, are your sines, and the y's, sorry, the x's are your cosines, and the y's are your sine ratios. So now it says complete the chart. So if you see, this is exactly the same chart that we did on the last page, except they've also included 0 degrees and 90 degrees. So what I'm going to do first is just fill in the 30, 45, 60, or the pi over 6, pi over 4, pi over 3 from the previous page, okay? So when I do that, this is going to be, the sine is 1/2, root 3 over 2, and root 3 over 3. Okay, for 45 degrees, this is root 2 over 2, root 2 over 2 and 1, and then root 3 over 2, 1/2, and root 3. Okay, so again, nothing new there. But what is new, okay, are the 0 degrees and the 90, okay, or the 0 and pi over 2 if we're discussing it in radians. So the sine of 0 degrees, remember sine is the y coordinate. So when you go up to 0 degrees and you look at the sine of 0 degrees, the y coordinate is right there. So it's simply 0. The cosine of 0 degrees is the x coordinate. That's right here. So cosine of 0 degrees is 1. And what's tangent, you guys? Remember tangent was calculated by going y over x, or opposite over adjacent. So y over x, which is really just the sine over the cosine, isn't it, right? So this is like saying sine over cosine. So here's the sine, here's the cosine. 0 over 1 is 0, okay? So that takes us to tangent. So tangent that takes me to 90 degrees, okay? So again, 90 degrees, okay? I'm going to go and look at sine of 90 degrees. So up here, here's sine of 90 degrees. Sine is the y coordinate. So sine of 90 degrees, or pi over 2, will be 1. Cosine is the x dimension, so that's going to be 0. Now, tangent of 90 degrees is actually going to be undefined. Why? Well, because it's y over x, which is sine over cosine. So the y, which is sine, so that's 1 over 0. And remember, in math, we cannot divide by 0. So the tangent of 90 degrees is undefined, okay? Now, follow follow along here, and Ian will fill in the blanks. So sine ratios increase from 0 to 1. Okay, they start at 0 and they go up to 1, and cosine ratios decrease from 1 to 0. Tangent ratios are equal to the sine ratios divided by the cosine ratios. Okay, and that's like saying the y's divided by the x's. Okay, so here is the unit circle. Now, the first time we see this circle, it usually makes our eyeballs pop out of our head, okay, because it looks so confusing. But remember, if I know quadrant 1, okay, so remember quadrant 1 is over here, okay, here is 2, here is 3, and here is 4. If I know quadrant 1, I know all the quadrants, and I'll show you right now. If I take this point right here, okay, which is a reference angle of 30 degrees, okay, so you can see there's your right angle triangle, that's how it's created, okay, and there's the dimensions √3 over 2, 1/2. If I reflect that over the y-axis, so flip it over the y-axis, you get this point right here, don't you? Well, look at the dimensions. They're exactly the same, or the coordinates, except that now the x is negative, because if I start at the origin, okay, to get to this triangle over here, okay, then I would have to go to the left, which would make the x coordinate negative, but the y value would still be positive. And then if I reflect that over the x-axis, okay, I would get this point down here. Same coordinates again, except this time both x and y are negative. And if I reflect that again to get into quadrant 4, to get this point here, okay, well, it's really the triangle up above, so just the y is negative, okay? So it's the same exact coordinates for all of those triangles, those reference triangles in each quadrant. But again, like I mentioned earlier, it's just the x or y that becomes negative when I do reflecting. See, again, if I take a look at 45 or pi over 4, that point, that point, that point, and that point all have the same numerical values, except for some of them being positive or negative depending on which quadrant we're in. Okay, and the same thing you could see for 60 degrees. Okay, so if I go to 60 degrees, okay, so this point gets reflected to here, down to here, okay, and across to here. Okay, and again, all those points, same coordinates, and the same would go for whatever's on the axis as well. Okay, so this point 1, 0 would be -1, 0. Okay, this point up here is 0, 1, reflected down here, 0 and -1. Okay, so again, looks very confusing when we take a look at it the first time, but when you understand that all the quadrants 2, 3, and 4 are actually reflections of what's happening in quadrant 1, okay, people usually calm down a bit and say that, okay, I can do this, okay, and it's not too bad. And again, you'll get so much practice at this that you know, it will become kind of second nature to you. So it says the circle above with a radius of 1 unit is the unit circle. So that's actually really important. Okay, when I'm on the unit circle, okay, the radius is always 1. And it understands, remember, sine is y over r. Okay, so that's y over 1, which would just be y. Cosine is x over r is 1, so that's x over 1, which is x. And then tangent is y over x, and cotangent would be x over y. We've seen those before. So example, like I said, sine is just going to be y, and cosine will just be x. Okay, and every point on the unit circle, xy, can be written in terms of cosine comma sine, because this is like saying the x coordinate and the y coordinate. Okay, so that's also really important. Okay, this point right here. Okay, so make sure you highlight that. Okay, and you can also maybe highlight these 2 points. Okay, tangent is sine over cos. Okay, because remember, tangent is opposite over adjacent, which is basically like saying y over x, right? Sine is the y, cos is the x. Okay, so let's get into some questions where we're using our calculators and see what they're actually asking us for here. So, okay, as it states here, it says use the unit circle. Okay, so whether you remember it or you have to refer to it on the page just across from you, find the exact value, okay, exact value of the trig ratios for a rotation angle of 300 degrees. Give each answer with a rational denominator, okay? So again, that's important. So you'll see I'll draw out what's happening here so you can understand what we're actually calculating. So they want a rotation angle of 300 degrees. So if I draw a rotation angle in standard position of 300 degrees, remember, here's my initial arm, okay? My terminal arm would take me over here, okay, into quadrant 4. Okay, so there is the rotation angle. But again, remember, I can't discuss the sine, cosine, and tangent of that rotation angle, okay, because it's bigger than 90 degrees. So what do? I use the reference angle. So the reference angle is right in there. So I draw that reference angle. I draw a reference triangle. Now that reference angle in there, okay, so the reference angle that I have drawn, okay, if I've rotated 300 degrees would obviously be 60 degrees. So that's where I go back and I think about, okay, my 60-degree triangle. What are the dimensions of my 60-degree triangle? So if you flip back, okay, you know, I've done it so many times, I know you guys will get there. If I look at my 60-degree triangle, the x dimension of that triangle would be 1/2. Okay, the y dimension of that triangle is root 3/2. Okay, it would be negative because I'd have to go to the right and then down. So here, the y dimension is negative, and we know the hypotenuse because it's the unit circle, right? They tell me that. Use the unit circle. I know the hypotenuse is 1. So all I have to do now is take a look at, sine, okay? Sine, I'm on the unit circle. Sine is always the y value, isn't it? So when I take a look at my triangle here, the y value is just negative root 3/2. That's it, okay? Sine is always opposite over the hypotenuse, but remember hypotenuse here is 1. So it's just the y value, negative root 3/2. The cosine is always adjacent over hypotenuse, or x over r, right? And it's just the x dimension, so it's just 1/2. Okay, it's just this x dimension of the triangle right here. And then we have to know the tangent of 300 degrees. Okay, well that's really, remember my reference angle is 60, so what's the tangent of 60 degrees? Okay, it's going to be negative root 3. Now how do I know it's negative? Well again, I'm in quadrant 4. Remember your cast rule, only cosine is positive in quadrant 4, so I know that calculation has to be negative. Now, the 3 that follow, okay, are a little more work. They're the reciprocals. So if I want to do the cosecant of 300 degrees, okay, it's going to look like this. So the reciprocal of cosecant is sine, so this would be negative, and then you'd have 2 over root 3, which is great, but I have to rationalize the denominator then. So root 3 over root 3, so this would be negative 2 root 3 all over 3. Okay, for secant, it's going to be reciprocal of 1/2, which is 2/1. So that's just 2. And then for cotangent, it's going to be the reciprocal of negative root 3. So it's negative 1/√3. Again, the denominator is irrational. So I rationalize the denominator. Okay, and this becomes negative root 3 all over 3. Okay, so there are the calculations that I do. Moving on, okay, use the unit circle to find the exact value of cosine of 3 pi over 4. So again, what I need to know here is where I am on the unit circle, what my rotation angle looks like, okay, and what my reference angle is. So again, they're giving me some in radian measure, some in degree measure here. So if you have to think in terms of degrees, that's fine. Okay, but again, the ratios don't matter, okay, if they're measuring it in degree or radian, the ratios will be the same value. Now remember, 3 pi over 4, well, pi, remember, is like 180. So 180 divided by 4 is 45, and 45 times 3, okay, would be 135 degrees. So that means that angle, 3 pi over 4, is basically 135 degrees. So I know that 135 degrees, okay, as a rotation angle would look like this. Okay, there's the rotation angle. Okay, I can't discuss the rotation angle because it's larger than 90. So I draw my reference triangle in here. Okay, and there's my reference triangle. Okay, and in this case, the reference angle, okay, would be 45 degrees, which is pi over 4. Okay, so we like pi over 4 because the 45-degree triangle, the two dimensions of the triangle are the same, root 2/2 and root 2/2. Okay, and this one's negative. So cosine in quadrant 2 is negative, which is the x, right? All we want is this. So this is negative root 2/2. Okay, the x dimension of the reference angle, which is root 2/2. Okay, that's all we're looking for here. When I move on to B, okay, the rotation angle they are talking about is 5 pi over 3. Okay, it's cotangent, so I'll have to go 1 over the tangent, won't I? So when I talk about pi over 3, okay, that's like 180 divided by 3. That's 6 times 5. That's 300. So I've got a rotation again of 300. Okay, so like so. There's what the rotation would look like. Okay, I discussed the reference angle, which is in here. So my reference angle in this case, okay, if I've rotated, what did I say? 180 divided by 3 is 300. So my reference angle is 60 degrees, right? 60 degrees is pi over 6. So for this one, I have a reference angle that is pi over 6. Okay, so you go to your 30-degree triangle, okay, and you think about what the tangent is. Okay, and then you have to basically reciprocate that, don't you? So what happens there is if I interchange the x and the y dimensions, you're going to get a calculation that's 1/2 all over negative root 3 over 2, okay, which will give you negative 1 over root 3, and then you rationalize that denominator, so you're going to have negative root 3 over 3, okay? Good. C, tangent of 600 degrees. So 600 degrees, okay, obviously you remove one full rotation of 360, okay, that's going to be the same then as the tangent of 240 degrees, okay? So if you're talking about the tangent of 240 degrees, okay, so there's your initial arm, 240, right, would be down here like so, okay? So there is 240, okay? Your reference angle is in here. Okay, so there's your reference triangle in there. So in this case, your reference angle, okay, if you've gone 240 would be 60 degrees. Okay, so again, you think about your 60-degree triangle, okay, and you think about what the x and the y dimensions are going to be. So this is going to be 1/2 negative, right, to the left, and negative root 3 over 2. Okay, those are the dimensions. So tangent is y over x, so negative root 3 over 2 over 1/2, okay? And if you know your table for 60 degrees, okay, that simplifies to root 3. The tangent of 60 degrees is root 3. Again, we're in quadrant 3, so tangent's positive there, so that's why, okay, it's a positive root 3. Next, cosecant of 3 pi, okay? So 3 pi, remember 2 pi is one full rotation, and then you add another pi, which is a half a rotation. So there's my initial arm. I would go around once, and then half a rotation, I end up right there. Okay, so remember when I'm on the axes, this point would be -1, 0, wouldn't it? Okay, and cosecant is the reciprocal of sine. Sine is the y value. So cosecant is 1 over the sine value, and anything divided by 0 is undefined. Okay, so there you go. Next, use a calculator, okay, our favorite phrase to see, to determine to 4 decimal places the coordinates of a point, and notice I'll highlight or underline on the unit circle that corresponds to a rotation of 2 over 5 pi. Now the reason I highlight that is because we learned that cosine is the x, so x of 2 pi over 5, and sine is the y, so sine of 2 pi over 5, or 2 over 5 pi. Now, this is going to be in radian, okay, so radians. So I would make sure my calculator is in radian mode. So go to mode, okay, go down to radian, make sure it's in that correct mode, and then 2 pi divided by 5 cosine of my answer, okay? So that is going to be 0.3090. They wanted it to 4 decimal places. And then the same thing for sine. So 2 pi divided by 5, 2 pi divided by 5, and then sine of the answer. So this gives me a y dimension of 0.9511. And there you go. There's the coordinates on the unit circle with those dimensions. Again, what is important? Cosine is the x, sine is the y, and I know that because it says on the unit circle. All right, next. It says point P, root 2 over 2, and negative root 2 over 2, and Q, which is -1/2 root 3 over 2, are 2 points, and again, on the unit circle. If an object rotates counterclockwise, so counterclockwise again is in this direction, Okay, from P to Q, through what angle has it rotated? Answer in degrees and radians. All right, so again, diagrams are our friend. So I'm gonna draw this out. Oops, that looks like EKG machine. Okay, so I'm gonna go like this, and I'm gonna label these points. So what I noticed with point P is these two are exactly the same, except one's positive, one's negative. That's our 45-degree angle, isn't it? Our 45-degree triangle. So it's at a positive x and then a negative y. So that's going to put me down here at point P. Okay, so there's point P right there. And then Q is a negative 1/2 and then root 3 over 2. So negative 1/2 root 3 over 2. That's going to put me up here, okay? There's the origin, and here is Q. Now, what do you know about negative 1/2 and root 3 over 2? When I have an x dimension that is 1/2 and a y dimension that's root 3 over 2, that's your 60-degree triangle, isn't it? So again, you know, being able to recognize those coordinates really quickly, okay, makes a huge difference. So here's why this is important. That point P, you went root 2 over 2 over and root 2 over 2 down. That means this angle in here is going to be, like I said, 45 degrees, okay? Or in radians, that would be pi over 4 radians, okay? Then, remember, I am rotating, remember, in this direction, okay? Counterclockwise. So then I'd have to rotate the whole way through quadrant 1, which would be 90 degrees or pi over 2 radians. And then finally, I'd have to rotate from here to here. Now, here's what I know. This Q, okay, comes from negative 1/2 and root 3 over 2, okay, which means, like I said, that this here is 60 degrees. I don't want that 60 degrees. I want this here because this is the angle it rotated. So that's 30 degrees or in radians, pi over 6. So if I answer in degrees, okay, it would be the 45 degrees plus the 90 degrees plus the 30 degrees, okay? So what do I get when I add those together? That's 165 degrees. If I go in radians, it would be pi over 4 plus pi over 2 plus pi over 6, okay? And that will give me, if I add them together with a common denominator, which would be 12, that's going to be 11 pi over 12, and those are radians. Now, I didn't have to do both calculations. I could have just done one and then used my conversion. For example, degrees multiplied by pi over 180 and reduce to get the radians. Okay, but hopefully that question makes sense. All right, the next one. Now, this question is a really good one. Okay, I would star it because it combines two chapters, logarithms with trig. So you'll see quite a few questions like this where they start to combine chapters because they can test you on your knowledge from previous sections. Okay, so without a graphing calculator, determine the exact value of log base 2 of cos 7 pi over 4. Okay, so here's what happens. The first thing I'm going to do is I'm going to figure out what cos of 7 pi over 4 is. Okay, so again, if I want to figure out what 7 pi over 4 is, okay, what you could do is pretend again pi is equivalent to 180. 180 divided by 4 times 7, so that's 315 degrees. So 7 pi over 4 is equivalent to 315 degrees. So if I had a rotation that looked like it was 315 degrees, okay, it would look like this, right? Which means then that my reference angle, which creates the reference triangle in here, this reference in here would be pi over 4, okay, which is 45 degrees, okay? So if I'm dealing with a 45-degree triangle, remember the dimensions are both root 2 over 2. So this is root 2 over 2. This would be negative root 2 over 2. And they're talking about the cosine, which is the x dimension. So this is what they want right there, positive root 2 over 2. So therefore, I can rewrite the question like this. Log base 2 of, and cos of 7 pi over 4 is just root 2 over 2. Okay, so there's step 1. You have to know what cos of 7 pi over 4 is. So there's the trig element to that question. What I can do from there is the following now. Go log base 2 of, okay, and then inside the brackets, the square root of 2 is the same as 2 to the exponent of 1/2 and in the denominator you have 2 to the exponent of 1, like so. So now, inside the brackets there, you're dividing powers that have the same base. So you subtract the exponents. 1/2 minus 1 is negative 1/2, like so. Then, using your power law for logarithms, I put the negative 1/2 in front, so negative 1/2 log base 2 of 2. Okay, and we should remember that when I have log base 2 of 2, so your base and your argument are the same, okay, that has a value that's equal to 1. So this is negative 1/2 times 1, okay, which is just negative 1/2, okay? And there's your final value. Negative 1/2 is your solution. Okay, moving on. The point A, which is at negative 0.6157, comma, negative 0.7880 lies, and again, very important, it lies on the unit circle. Determine the value of theta, which is the unknown angle, where theta is the angle made by the positive x-axis and the line that goes through A. Now, what you'll notice is both of these dimensions are negative, okay? So that means automatically you would be in quadrant 3, right? So if your x is negative, you go left. When your y is negative, you go down. That takes you into quadrant 3. And because it's on the unit circle, I know the x is your cosine. So cosine of your theta will equal the x value, negative 0.6157. And I know the y dimension is sine because it's on the unit circle. So sine would be the negative 0.7880. So what you can do is using either, it doesn't matter, the sine or the cosine value, is we would want to find the reference angle. Okay, so when I find the reference angle, for example, I can go sine or inverse sine of 0.7880. Okay, and when I do that on my calculator, okay, you're going to see that that gives me 52 degrees. Okay, now again, you could have done that in radians, but again, degrees works out nicely to 52 degrees. So since I'm in quadrant 3, what would I do in quadrant 3? I would take 180 degrees plus my reference angle, okay, and I'll get that rotation angle, which ends up being 232 degrees. But you can see how important that phrase on the unit circle is, okay? Cosine is your x, sine is your y. Okay, next page. Alternative methods using the unit circle, using reference triangles. So this is kind of what I've been showing you all along here. Now, they've just repeated the table and it says this chart should be memorized. And to some degree, yes, okay. Remember that it's not your only way to calculate things. You should always be able to figure out the x and the y dimensions of those special triangles. But if you can't, okay, memorizing that chart and knowing the dimensions specifically of the 30, the 45, and the 60 will help you out. Remember, the radius is always 1 when we're on the unit circle. So here's what they're talking about. Complete the work below and determine the exact values of the following. So what they've shown you in question 1 here is a rotation angle of 210. So that rotation angle of 210 is actually from here to here, isn't it? But they're saying when I have that rotation of 210, I'm worried about just the reference angle and reference triangle, which is created in here. So there's the reference angle. So yes, I rotated 210 degrees, but that gives me 30 degrees as the reference angle. Okay, and there's the little reference right angle triangle that's created between the terminal arm and the x-axis. So what do I know about that triangle? Well, when I have a reference angle that's 30 degrees, okay, the dimension of that triangle, again, is root 3 over 2 and 1/2. But because I'm in quadrant 3, you would go left, negative, and then down, negative, okay? Hypotenuse is always 1. That's kind of what you always want to draw. So here's what they're saying. In quadrant 3, sine ratio is negative, isn't it, right? And we know that, okay, because of our cast rule, right? Here in quadrant 3, only tangent's positive. So the sine of 210 is the same as negative sine 30. So sine of 210 is going to be negative 1/2. Okay, there you go. It's just that value right there. That's all that they're talking about. Okay, so let's do the same thing with the next question. So cosine of 5 pi over 3. Well, remember 5 pi over 3, okay, is the same as what though? Well, 180 divided by 3 okay, is 60 times 5. That would be 300. So again, not that I'm going to do everything in degrees, but a lot of times it helps if we understand kind of what we are discussing and what we're looking at in terms of a rotation and reference angle. So a rotation, obviously, of 300 degrees would look something like this, or 5 pi over 3 radians. So there's the rotation. Again, the reference angle is in here, right, between the terminal arm and the x-axis. Okay, so I create my reference triangle. So that reference angle in there, if I rotated 300 degrees, would be 60 degrees. 60 degrees is pi over 3. So there's my reference angle, pi over 3. So think about your 60-degree triangle, or pi over 3. So when I have my 60-degree triangle, that means the dimension is now, the x is now 1/2. The y is root 3 over 2. And because you would go right, that's positive, and down, that's negative. So in quadrant 4, the cosine ratio is positive, isn't it? So cos of 5 pi over 3 is the same as the cos of pi over 3, right? 5 pi over 3 is in quadrant 4, and pi over 3 is the reference, okay, in quadrant 1. So they're both positive in both quadrants. So cos of 5 pi over 3 is just 1/2. It's the x dimension right there, okay? All right, next one, a little trickier just because we have a tangent of negative 225, which means we rotate in that direction, okay, which is the clockwise direction. So if I draw a rotation angle of negative 225 degrees, okay, that's going to put me here, okay, in this quadrant. So when I talk about the reference angle again, okay, between the terminal arm and the x-axis, so there's my reference triangle, there's the reference angle right in there. So what's that reference angle going to be? Well, it's going to be 45 degrees, okay? So the reference angle in this case is 45 degrees. So we like the 45-degree triangle because remember the x and the y dimensions are the same, okay? Negative root 2 over 2 and root 2 over 2, hypotenuse is 1. So what we do is the following. Like I said, reference angle is 45 degrees. In quadrant 2, right, which is the quadrant we're in, tangent is negative, isn't it? So the tangent of negative 225, which is what they're looking for, would be equal to the tangent of 45 times negative, right? Because tangent of 45 is quadrant 1, but multiplied by a negative. Really, all they're looking for here is tangent, which remember is opposite over adjacent, so root 2 over 2 over negative root 2 over 2. So that has a value of negative 1. That's your answer, okay? Y over x, they're both the same value here. One's positive, one is negative. Okay, last page in a bit here. The equation of the unit circle. So it says use Pythagorean theorem to determine the equation of the unit circle. Well, the equation of the unit circle, because we have Pythagorean theorem, okay, is basically this. X squared plus y squared equals 1. Now why 1? Well, because remember, it's actually x squared plus y squared equals r squared. But on the unit circle, your value of r is always 1. So 1 squared, okay, is 1. So that's why it's x squared plus y squared equals 1. So it says now the equation of a circle with a center O and a radius of r. So if I just have a radius of r, okay, not 1, well, then that equation of the circle, okay, is just x squared plus y squared equals r squared. Whatever r is, you're going to square it, okay? But the important one is this, okay? The equation of the unit circle is x squared plus y squared is equal to 1. So the reason that's important is because they'll ask you questions like this. Determine which of the following points lie on the unit circle. Well, if it lies on the unit circle, x squared plus y squared should equal 1, right? So x squared plus the y value squared, right? This was an x, this was a y. So I'm squaring them. If it's on the unit circle, it should equal 1. So this is 1 over 4 plus 1 over 4. That's 2 over 4, which is 1/2. That's 1/2. 1/2 does not equal 1. So no, this point is not on the unit circle. Okay. You take the next point, right? So again, this is an x, this is a y. So if I go 16 over 65, the x squared plus the y value squared, okay, that should equal 1. If it does, it's on the unit circle. So if I take that and do it on my calculator, okay, again, you can do it also with, not using your calculator, using fractions, okay, you will see that this does equal 1. So yes, this is on the unit circle. Okay, and then the last one, same thing. This is an x value, this is a y value. So you go negative 2 over 3 x squared plus the y value squared, okay? See if that equals 1. If it does, it's on the unit circle. If it doesn't equal 1, not on the unit circle. Okay, so this does equal 1, so yes, this point is also on the unit circle. Okay, now the point P, which is negative 1 over 5 and y, key phrase again, lies on the unit circle, and they even tell you the quadrant that you're in, quadrant 3, determine the value of y. So the reason that's important is, okay, the following. So we're in quadrant 3, okay, which means I also know that the y value will be negative, okay? So it's on the unit circle, okay, which means I can take my equation, x squared plus y squared equals 1, because they say it's on the unit circle. So when I solve for y, so y squared will be then 1 minus 1 over 25. Okay, that's what negative 1 over 5 squared is, and I bring it to the other side. Okay, so when I do that, that means I will get y squared will be 24 over 25. Okay, then I have to square root both sides. Okay, so y will equal the square root of 24 over 25. That will be root 4 root 6, so 2 root 6 all over 5, okay? And because I'm in quadrant 3, it has to be negative. So there's the value of y, okay? Again, remember, you're starting at the origin, you're going left, which is negative, and you're going down, which is negative, okay? So that y dimension would be negative. Now, the point P, okay, again, P, remember, comes from that original point, is on the terminal arm of a rotation angle. So we're just going to draw out what they're talking about again so you can see what I am calculating. So there is the vertex, there's the initial arm. I'm in quadrant 3, so there's the terminal arm that I'm discussing, and there is point P, okay, which we now know has a coordinate of negative 1 over 5 and negative 2 root 6 over 5. There's the x and the y coordinate, okay? So they want to know the values, okay, of secant of theta and cotangent of theta. So there is my reference angle, my rotation angle. So that triangle, the dimension of that triangle is this, negative 1 over 5 and negative 2 root 6 over 5, hypotenuse 1 of that red triangle because we're on the unit circle. So if they want secant, okay, secant is the reciprocal of cosine, isn't it? So cosine of my angle, remember, x over r, okay, or the x dimension, negative 1 over 5. So therefore, the secant of theta, okay, would just be the reciprocal of that, 1 over negative 1 over 5, which would just be negative 5. So there's the easy one, okay? Secant of theta is negative 5. Okay, cotangent of theta, okay, is the reciprocal of tangent. So let's take a look at tan of theta. Now, tan of theta is going to be y over x. So tangent, when I look at it, is the y over the x. So that would be negative 2 root 6 over 5, okay, all over negative 1 over 5, okay, like so. So when I want cotangent, it's going to be the reciprocal of that. You're going to have negative 1 over 5 all over negative 2 root 6 over 5, okay, the opposite of that. So this works out to be negative 1 over 5 multiplied by the reciprocal. So the 5 all over negative 2 root 6. So the negatives will cancel. The 5s will cancel. So you will have 1 all over 2 root 6. Okay, you want to rationalize that root 6 from the denominator, like so. So you're going to get root 6 all over 12. There's your answer. Okay, root 6 over 12. Okay, and then the third part says determine the value of theta to the nearest tenth of a radian. Okay, so when they tell you tenth of a radian, okay, and again, there's your domain. Okay, they only want in those 4 quadrants. Okay, that means you can use your calculator, right? So I'm just going to go like this. Well, I know cos of theta is -1/5, okay, and that's in quadrant 3. So to find the reference angle, okay, I'm going to go second function or inverse cosine of 1/5. Okay, that's going to give me my reference angle. So when I do that, remember radian mode this time, because they tell you to the nearest tenth of a radian, you're going to get 1.3694, etc. So since I'm in quadrant 3, you're going to go theta plus your reference angle. Okay, like so. Theta will equal pi plus your reference angle. So theta therefore will equal, okay, pi plus my answer to the nearest tenth, 4.5 radians. Okay, last question. Determine the equation of a circle that has the center at the origin and a radius of 8 units. Well, we learned on the last page the equation of any circle is actually x squared plus y squared is equal to r squared. Well, in this question, they say the radius is 8. So this is just going to be x squared plus y squared will equal 8 squared, which is x squared plus y squared is equal to 8 squared, okay, 64. Okay, so pretty straightforward. Now, the last part says if the point -4 and then b root 3 lies on the circle, determine all possible values of b. So again, the key phrase here is that it lies on the circle. Now, not the unit circle, but on this circle. So what I would do is, again, this is an x, okay, and this is a y coordinate, and it lies on my circle. So there's my x squared plus y, there's my y coordinate squared, must be equal to 64. So 16 plus, this is going to be 3b squared, when I square it, equals 64. Okay, I'm going to bring my 16 to the other side of the equation. So 3b squared will be equal to 48. Divide both sides by 3, so that gives me 16. And then when I square root 16, okay, that means b could be either positive or -4. And there you go. Okay, so that might be one of the tougher sections that we have done all year. Okay, so again, please take your time with it. Take a look at the unit circle. Know that sine, okay, is the y dimension of your triangles in the unit circle. Cosine is the x. Okay, memorize your special triangles and their side lengths. You will need them a ton moving forward, okay? So practice that. I hope you guys are doing well. Sorry for the super long lesson, okay? But it is just material that we need to get through. So again, let me know if you have any